I would like to look at just a couple of problems involving consecutive integers. And these problems often cause some grief for students, but they're really not that hard. We're going to first understand what do I mean when I say a consecutive integer. Well, that's pretty simple. If I were going to name consecutive integers beginning with the number 5, okay, that might be my first number. And if it's a consecutive integer, then my next number would be, or my next integer would be 6. My next integer would then be what? 7. That's what that word consecutive means. It means one follows the next. But what if I asked you about consecutive odd integers? If we start with 5, the next one would be what? 7, yeah, odd, right? Or the next one would be 9. Well, I can't start with 5 if I want to talk about even integers. But I could start with 6, because 6 is an even integer. So if I start with 6, the next one would be 8. Next one would be 10. Sure, okay. So that kind of makes sense. What if I wanted to write an expression to represent those? For example, let's say let x equal 5. If I wanted to write an expression for that, then I say, well, x is 5. The next integer would be 5 plus 1, or x plus 1, right? Because 5 plus 1 is 6. You understand what I'm saying? I'm just writing an expression for that. And then if x is 5, x plus 1 is the next integer. The integer to follow that's x plus 2. Well, that kind of makes sense. Let's talk about that then with even integers, or odd integers. Let's start with odd. Let's let x equal 2 here. Or let x equal 5. Let x equal 2, 5. Okay, so if I want to write that as an expression, if x equals 5, then my first integer would be 5. But what would my second integer be to get 7? How did I get from 5 to 7? Yes, sir.
If x equals 5, then your next consecutive integer would be 10.
Would be what?
10.
Well, no, not my next odd. If x is 5 and I want to find the next odd integer, I may have said that wrong. X plus what? 2. Yeah, Caden. Thank you. I may have asked that question kind of bad. I apologize. So if my first odd integer is 5, my next one is x plus 2, because odd integers are 2 units away, aren't they? What would be my next integer then? If the first one's x, the next one's x plus 2, what's the next one going to be? The next odd integer, x plus what? 4. Yeah, 4. I mean, check it out. If x is 5, 5 plus 2, 7. 5 plus 4, 9. So that works, doesn't it? Okay, so I had the expressions for just consecutive integers, one after another, x and x plus 1, and x plus 2. And then I've got my odd integers. If it starts with an odd one, x plus 2, x plus 4. So wonder what it'll look like with even integers. Well, let's let x equal 6. And I'm going to do 6, 8, 10. My first integer would be x. What would my next one be? X plus, yeah. Ooh, that looks like the odds, doesn't it? What would my next one be? Yeah, x plus 4. Here's the thing. When I'm talking about consecutive integers, if I start with an odd one, the next odd integer is 2 away. If I start with an even integer, the next even integer is still 2 away. So really, there's only 2 ways we're going to look at these expressions. We'll either say, well, it's odd, x plus 2, x plus 4, or it's even, x plus 2, x plus 4. Both of those will look the same, or they're just going to be consecutive integers. So that's kind of important information for the type of problems we're going to look at. So let's see what that looks like in a word problem. The sum of 3 consecutive integers, that's integers that follow one after another, is 48. So there's some key words there. First key word I see is sum. Means if I add 3 consecutive integers, then that sum is typically always means equals, is 48. So if I add 3 consecutive integers, the answer is going to be 48. Find the 3 numbers. Well, remember a minute ago when I was looking at these, I said we were writing it as an expression. Then the first one was x, right? And if it's consecutive, what's my next one? X plus 1. Because it's not even or odd, it's consecutive. What's my next one then? X plus, right. And I know it equals 48. So here's how I'm going to solve that. Remember sum, so I just add those together. It equals 48. So what I've done is I've taken the problem and I've written it into an equation. Okay? Be sure you jotted that down because you're going to see some of these in just a minute. Well, I know how to solve an equation because I've been working on that for several days now. And I'm going to combine like terms. Remember, this x really is 1x. And that is 1x. And so if I combine like terms, 1x plus 1x plus 1x is actually 3x. And 1 plus 2 is 3. And so I can really simplify that equation down to be 3x plus 3 equals 48. Write that down. Okay? So I know how to solve the equation from here on out because I've done that for several days now. I know that using the subtraction property of equality, I can subtract 3 from both sides. And because these are inverse, it's the inverse property of addition. They cancel each other, leaving with a 0. So I have 3x equal 48 minus 3, which is 45. Then divide by 3, x will equal 15. So what I did is I found my first integer. Remember, my second integer then is x plus 1. So that's 15 plus 1, or 16, and x plus 2, which is 17. So if I add those 3 up, I get 48. So I've solved it. And so I might want to summarize that in words. So 3 consecutive integers whose sum is 48, are 15, 16, and 17. Always a good idea to turn around and put my word problem answer back into words. I'm not sure my grammar's perfect there, but I think it's close. Let's look at another very similar problem. Looks a lot the same, except this time it says the sum, which means to add, 3 consecutive. Now this time it is even integers, okay? Is, which means typically equals 48. So we're going to find those 3 numbers. Now, just based on what we start out with, if they're consecutive even or if they're consecutive odd, then I would say, well, x is my first number or first integer. And then my next one, my next even integer, is not x plus 1. Now it's x plus what? Because it's even, it's x plus what?
X plus 6. Wait, 3 it's you on the street.
My second one is going to be, if my first integer is even, it's x. My next one is 2 away, or x plus 2. That's my second integer. And what's my third integer? You got it. What are you going to say? X plus 4. Yes. Okay, so the only difference in this problem is now because they're evens, every integer is 2 what? Okay, so the sum of those means, I need to take each one of these and add them. So just like I did before, it's x plus 2 plus x plus 4, and that equals, I believe I said 48, right? That's what I said, right? Yep. So that problem doesn't look much different than when it was just consecutive integers, with the exception of, as I wrote each one of those down, now it's x, not plus 1, but x plus 2, and then x plus 4, and I'll find those numbers. So combining like terms, 3x plus 6 equals 48. Subtraction property of equality, subtract 6 from both sides. Those will cancel because it's the additive inverse. 3x is equal to 48 minus 6, which is 42. Then use the division property of equality and divide by 3. Those are multiplicative inverses, so I'm left with x equals 42 divided by 3, which is 14. So if x is 14, x plus 2 would be 14 plus 2, or 16, and x plus 4 would be 18. When I add those up, I'll get 48. Are they even? Yes, they are. Are they consecutive? Yes, they are. So 3 consecutive even integers whose sum is 48 are 14, 16, and 18. So that's how we're going to write and solve problems concerning consecutive integers, consecutive even integers, or consecutive odd integers.